Okay, my name is Barrett. I'm at the George Washington University. I'm going to break up this VLBI talks with something slightly different, something more fundamental to, speak in the microphone, please. Yeah. So more fundamental to Julia in astronomy, and that is that's Astrometry.jl, okay? We need several fundamental packages to actually do astronomy. Astrometry.jl is one of them. What's the motivation for Astrometry.jl? It's basically, the idea is, I want to do this for a while, is to implement the SOFA or IRFA packages. SOFA stands for Standards of Fundamental Astronomy, put out by the IAU, that they've been doing for the last 30 years or so. There are two basic packages that they put out. One is in C, the other is in FORTRAN. And the idea is to create a package, a pure Julia package that people can use, which duplicates those astrometric algorithms, okay, to do precession, nutation, et cetera. Time changes, all that type of stuff that's part of the SOFA package. And the idea is to have, a high performance package, okay, written purely in Julia so that it's easy to install, and also to minimize the functionality, to keep it simple, okay? SOFA itself has 247 functions, okay? Of course, many of them are dependent type functions, but it's a complicated thing to look at, all right, and to understand initially. And the idea was to simplify this and make it easy for the user. So the current functionality is very basic. It just has in there what I need right now, is basically to do precession and nutation type work, and also proper motion. I mainly use this to convert from JD to barycentric Julian time, okay? Basically, I need to convert all my observations to barycentric, particularly the time, to do proper time series analysis. And so that's the major motivation for that right now. The current model, or the functions that I do have, do implement all the models from 1980 to 2000, the A and B versions, the 2006 and 2006F, and 2011 and USNO. The 2006 tends to be the default model that most people use, but you do have an option for all of those. So as part of this, to make sure that the algorithms are correct, I actually rewrote or re-implemented all the SOFA packages. And so there's a subpackage called SOFA, which contains the 247 functions written in Julia. Many of those functions are just single lines. They're just very simple, but the idea was to have a complete implementation. And therefore, the benefit is it's a drop-in replacement to the C-wrapped packages of SOFA and IRFA, okay, that are available. There's SOFA.jl and IRFA.jl, but many people are using. Well, you can now use astrometry.sofa and get the same functionality. And so the performance is comparable to them. In fact, I think in arrays it's higher performance because the others are C, and you have to, there's actually the overhead. If you're doing multiple objects, like 1,000 different transformations or something, then you have those C calls you have to deal with. And Julia can vectorize that. And so the SOFA subpackage is designed to confirm that everything is working properly. So plan improvements. So I have worked recently on improving SOFA mainly by getting the performance up. I've done a lot of optimizations on that. And so it's almost all of it is faster than the C counterparts. And the other aspect that I did change recently, this hasn't been released yet, is instead of having everything as a float 64 type, I'm now using abstract floats. The benefit there is that you can now use big floats or, what's the other one? Or double floats to actually do your calculations. So you can get 30 significant digits if you need to. That works without, just out of the box without any problem. And the reason for that, let me just say, is the reason for that, I had worked with the master clock and basically in time series analysis. And, you know, in the next 5 to 10 years, there will be optical clocks and nuclear clocks, and they will have precision of 1 part in 10 to the 20, all right? And I think in terms of radio astronomy, we need to be prepared for that, okay? Current clocks are now 1 part in 14, 1 part in 15. This will be several orders of magnitude greater. Astrometry, that needs more development to simplify, but we are working on that, or I'm trying to work on that and add more functionality to that. The big issue right now is time frames and reference frames, and working out a much better system for that. We do have that in astronomy, but I think I think we need to do better. So the next version that will come out is 0.3. I hope to release that in the next month or so. Most of those changes will be to the SOFA packages. And finally, there are basically 2 versions of the SOFA astrometric algorithms. So that's nice that we actually have a Julia version out there. The other thing is people at the IOU SOFA actually contacted me, so I've given them an abstract, and so on their web page, this package will be advertised, which I think is a little bit of a help to make sure to let people know that it's out there. For anyone who's thinking about using this, please, if you've got requests or features you want done, please submit them to me or submit PRs or whatever, and so we can move this along, because I think it's very fundamental. It is a fundamental package that we all need to have. And I think it's very important as we move forward, because with these large telescopes like Rubin and Roman, where you've got millions of objects and you have to possibly do precession on them and that type of stuff, I think Julia will be a big advantage in that respect compared to what we have now. And the last thing I want to note is, to go along with this, is that FORTRAN version 2 is out there. You can now actually read. It's a pure Julia version for reading and writing FITS files. That's available, so you might want to take a look at that, because there have been problems with the CFITS.io building that, and this gets around that. That's all. Thanks.
Questions for Paul?
Hi there, thanks for the talk. So I'm actually an amateur astronomer. I do a lot of imaging just as a hobby. Do you know if people in the amateur astronomy community are using this, or has this been mostly confined to like professional or like, in academic settings?
This package?
Yeah, this package, or like in general with the Julia ecosystem, I've noticed.
Or Julia? Yeah. I'm not aware of any amateurs using Julia. I mean, they tend to use standard software that other people have written their packages out there for doing amateur astronomy. They tend to use that, yeah.
I feel like I've seen 1 or 2 packages for kind of basic image analysis.
Yeah,
but
I've been hoping to do both image processing, but also maybe some like hardware development with Julia. So that's been on my mind, but it's also been like I have to learn a lot about hardware development part. So
cool.
So I don't know if this is a feature request or a question about whether it's on your timeline, but I'll say this again. I think this has happened on Slack several times. Barycentric correction for radial velocities do not currently exist in Julia to high enough precision. Is that a planned part of astrometry? I mean, you still need, you need to have support for where the observatories are, but everything else you basically already have, and then it's just implementing things like Shapiro delay and a bunch of other complicated stuff. So maybe you also have opinions on that. Yeah, and leap seconds.
But we have just discussed this. If you could provide, an algorithm or a flow chart of how that would be done, then yeah, that could probably be done much more easily. So,
Okay, I would be interested in providing that, because it's a real bottleneck, I think, that it's not yet in Julia.
One of the big issues that that does need to be done is, the ephemeris, and that needs to be, you know, the really accurate JPL ephemerises need to be added to get accuracies of, you know, 1 second or less in terms of barycentric.
Yeah, I think a bunch of the ephemerises were recently added, actually. There's these separate ephemeris packages requiring the JPL ephemerises.
But SOFA has the default, you know, DEO5 or something like that ephemeris, and that's what I'm using now, but I don't have all the other ephemerises in there.
I think in the RV community, Barry CorePy is kind of the standard. I believe it's querying the JPL ephemerises to basically do the hard work for it, and then doing a few things on top of that. So there's a reference, you know, something you can compare to. For
Right. Well, there is software. The people who do spacecraft type stuff already have. There is a package that does all of this. We just need to integrate them.
This is actually about FITS files. If FITSfiles.jl like doesn't segfault, that's already great compared to CFITS.io. But I guess I'm also wondering if you've done any performance comparisons. Like, is it similarly? Is it like roughly the same speed? Is it faster? I feel like that's probably possible. Do you know?
I don't know. I've just been working on the functionality at this point, you know. I mean, FITS is difficult to implement. So, you know, it's to the point where we've got the basic functionality. You can't expect for the world coordinate systems, that's not there, and there's a bunch of other features that need to be added in point 2. But you can basically read in a FITS file. I mean, you know, I can read in CRISM files which use bit vectors and that type of stuff. So, you know, you can actually do data analysis. I do use it for data analysis. But if you want to do more advanced stuff, then you got to roll your own kind of thing. But I think it's, you know, it's probably comparable. I don't see why it wouldn't be. You know, I think you know, if you're reading in binary tables, it's kind of slow. I just haven't optimized that. I'm sure that could be done. The other thing is I read in the entire file at one point in time, and I realize that's a bottleneck, but, you know, I'll change that in the future. That's an optimization, right? I just want to get to the data.
Let's thank Paul again. Next up is Iridani Chavez.